Hello everyone, in this video we are going to discuss about quantum computing. What is quantum computing? Quantum computing is a type of computation that harnesses the collective properties of quantum states such as superposition, interference, and entanglement to perform calculations. The devices that perform quantum computations are known as quantum computers. Though current quantum computers are too small to outperform usual computers for practical applications, they are believed to be capable of solving certain computational problems such as integer factorization substantially faster than classical computers. The study of quantum computing is a subfield of quantum information science. There are several types of quantum computers, including the quantum circuit model, quantum Turing machine, adiabatic quantum computer, one-way quantum computer, and various quantum cellular automata. The most widely used model is the quantum circuit, based on the quantum bit or qubit, which is somewhat analogous to the bit in classical computation. A qubit can be in 1 or 0 quantum state or in a superposition of the 1 and 0 states. When it is measured, however, it is always 0 or 1. The probability of either outcome depends on the qubit's quantum state immediately prior to measurement. Efforts towards building a physical quantum computer focus on technologies such as transmons, ion traps, and topological quantum computers, which aim to create high-quality qubits. These qubits may be designed differently depending on the full quantum computer's computing model as to whether quantum logic gates, quantum annealing, or adiabatic quantum computation are employed. There are currently a number of significant obstacles to constructing useful quantum computers. It is particularly difficult to maintain qubits quantum states as they suffer from quantum decoherence and state fidelity. Quantum computers therefore require error correction. Any computational problem that can be solved by a classical computer can also be solved by a quantum computer. Conversely, any problem that can be solved by a quantum computer can also be solved by a classical computer, at least in principle given enough time. In other words, quantum computers obey the Church-Turing thesis. This means that while quantum computers provide no additional advantages over classical computers in terms of computability, quantum algorithms for certain problems have significantly lower time complexities than corresponding known classical algorithms.
So quantum computer versus classical computer. Quantum computers process information differently. Classical computers use transistors and are which are either 1 or 0. Quantum computers use qubits which can be 1 or 0 at the same time since it is very small. The number of qubits linked together increases the quantum computing power exponentially, while linking together more transistors only increases power linearly. So it is very different. The classical computers are best for everyday tasks that need to be completed by a computer. Meanwhile, quantum computers are great for running simulations, data analysis, as per chemical and drug trials. These computers must be kept ultra cold, however, they are also much expensive and difficult to build. Classical computing advances include adding memory to speed up computers. Meanwhile, quantum computers help solve more complicated problems. While quantum computers might not run on Microsoft Word better or faster, they can run complex problems faster. For example, Google quantum computers that's in development could help many processes such as speed up machine learning, training, or help create more energy efficient batteries. Quantum computer has a number of other applications, including securely sharing information, other method of fighting cancer and various health concerns, such as cancer and developing new drugs, as well as quantum computers can help improve radars as their ability to detect such things as missiles and aircrafts. Other areas include environment using quantum computing to keep water clean with chemical sensors. Real-world example of quantum computers. Google is spending billions of dollars on its plan to build its own computer by 2029. The company have opened a campus in California called Google AI to help meet this goal. Google has been investing in its technology for years as well as other companies such as HON and IBM. Expects to hit more quantum computing milestones in the coming years. And that's all. Thank you for watching.